Okay. So this is graphing a scatter plot with line of best fit part 2. In part 1 of the video, we got this far. We were using graph paper. I don't have graph paper, but I have a nice grid up here. You can't see it, but I've got little tick marks that guide me where I draw my ruler. Notice I have the ruler in my hand most of the time. So if you're graphing and you don't have a ruler next to you, you better get a ruler because I expect your lines to be straight. We established a linear x-axis for volume, our independent variable, and we established a linear y-axis for mass, our dependent variable. Then we plotted our experimental data from the lab. We plotted our mass versus volume data, which are these x marks here, and then we drew a line of best fit, and that's where I had to end the video yesterday. So the next step is I want you to calculate the slope, and your math teacher may call it the ratio method. I just call it rise over run. So what I want you to do is look at the grid on your graph paper and try to find a point on the lower end of the line that goes right through the grid, that goes through an intersection of the grid points. For example, at my grid line, that's at 30. It intersects with my grid line at y equals 30. So I've got a nice intersection of the grid on my graph that falls right on that line. And so if you look down that line, you'll see where the square is a little above, the square is a little below, but you'll find a point right where the blue lines intersect on your line of best fit. Try to find 2 points, one low, and then try to find one high. All right? So on my high end, I've got this point. Okay, the slope of the line is rise over run. And I saw one video teacher say the way he remembers it, you have to rise up in the morning before you run off into your day. I don't know, rise over run. Okay, so what is the rise? The rise is the y-axis. So we need to figure out what this distance is. Well, this distance is just whatever the value is on the axis here, subtracted from the value of the value on the axis here. So if this is 130 and this is 30, what must this distance be? 100, right? So our rise is 100. Our run, and this is just almost too coincidental, too perfect. Here, it's 130. And here, it's also 30. Here, 30 also, like compared to that. So what must this distance be? 100. So the run is 100 also. So 100 over 100 is 1. It's 1. Right? So the rise over run is a slope of 1. This is almost a bad example because it works out too well. But you certainly can understand that if you have a steeper line or a shallower line, that the rise over run numbers are going to be different. Okay? But here's the revelation, or here's what you need to understand. Graphically, the slope was 1, and when we did it by calculating an average, what was the value? 1, right? Because if you, again, I want to make sure you got the connection. To get this average, we divided the mass by the volume. To get this slope, we divided the mass by the volume. So you can compare the answer that you get graphically with the answer that you get mathematically, because you had this scattering of data, but when you drew the line of best fit, you were actually averaging the data visually. Right? Okay. So the density of our mystery fluid is 1. Does anybody know what the identity of the mystery fluid is, by the way, now that we've calculated the density? What is it? Good. Who said that? Candy. You get candy. Hey, I told you I was going to make the perfect graph up here so you'd know what my expectations were. What is this graph missing? A title. When you title your graph, what I want you to do is just call it y versus x, and in this case it's mass versus volume. It's a descriptive title. Yeah, you could say density of unknown fluid. But it's really easy. It's like, I can't think of a good name for my title. The most descriptive title is just say dependent variable versus independent variable. Okay, good.